Hello, this movie is for Unit 6, Learning Target 5. Determine if a quadrilateral is a parallelogram. We're going to start off with theorem. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if we've got a four-sided figure that has opposite sides congruent, we know we have a parallelogram. That's our first theorem. Our second one, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then it's a parallelogram. This makes sense. If A is supplementary to B, that tells me that these two lines are parallel. And if A is supplementary to D, that tells me these two lines are parallel. So we get a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if we have these opposite angles congruent, we know we've got a parallelogram. And these are all properties of a quadrilateral that give us a parallelogram. Let's look at this problem. For what values of y must PQRS be a parallelogram? Well, in order to be a parallelogram, we know that opposite sides will be congruent. So I can set these equal to each other and these equal to each other. I'm going to solve this equation. And I get x equals 6. Then for the other two, the x plus 2 equals y, I'm going to plug in 6 for x. And I get 8 for y. So when x is 6 and y is 8, I know that I have a parallelogram. Let's look at this problem. For what values of x and y make this a parallelogram? Well, we'll know that opposite angles will be congruent, and we know that consecutive angles will be supplementary. If I set opposite angles equal to each other, you'll see that we'll get a system of equations, which we could do, or what we could do is do same side interior here, consecutive ones supplementary. So the 3y minus 2 plus y plus 10 will be equal to 180. And then go ahead and solve. And then we get y is 43. So what we can do is plug that back in to get our angle measures. So 53. That tells me that this angle will be 180 minus 53, 127. So I can do 12x plus 7 equals 127. And I get x equals 10. So when x equals 10 and y equals 43, I get a parallelogram. Now you can double check this by plugging these values in to make sure opposite angles are congruent and consecutive angles are supplementary. Our next theorem, if the diagonals of a quadrilateral bisect, meaning to cut in half each other, then the quadrilateral is a parallelogram. So if diagonals bisect or cut each other in half, then we have a parallelogram. We're going to do a proof of that theorem. So what we're going to start off with in our given is that AC and BD bisect each other at E. You can see that written right here, so this is going to be given. Now, bisecting each other means angle AEB, this angle, CED, this angle. Why would those angles be congruent? Vertical angles congruent. And notice over here, BEC, this angle, is congruent to this angle, also vertical angles congruent. Now you'll see I'm dealing with different triangles here, and so I wanted to use a flow proof because many of these are going to be the same. Notice in the middle here, AE congruent to CE, BE congruent to DE by definition of segment bisector, or just definition of bisector. Then what causes these two triangles to be congruent? AEB and CED. You can see, well, let's look at this too. BEC, these two triangles would be congruent by what? It is side angle side for these, as well as side angle side for these. Then what allows us to say BAE congruent to DCE? Those are alternate, oh, that's bad writing, interior angles congruent when lines are parallel. Then over here we've got ECB congruent to EAD, and this is alternate interior angles congruent when lines are parallel. Then we've got, oops, we are going to just erase something here. I can't say that yet. I say these are congruent by CPCTC. You're going to have to erase that because I'm not going to remake the movie. So those are corresponding parts of congruent triangles are congruent. My bad. They are alternate interior angles, which is why we can say lines are parallel here. So if alternate interior angles congruent, then lines parallel. And that's true over here as well. If alternate interior angles are congruent, then lines are parallel. Now that we've established opposite sides parallel, we can say that it's a parallelogram based on definition of parallelogram. So I kind of like this proof because you can see that you've got two different things going on that all relate to get the opposite sides of the parallelogram parallel. Our next theorem, if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So this one is obscure. A lot of people miss this one. It's a property that if you've got just these two sides are both parallel and congruent, then you have a parallelogram. So this one is one that is not as obvious, but a property that will give you a parallelogram. Let's see how these relate. Can you prove that the quadrilateral is a parallelogram based on the information? What I want you to do is I'll walk through A for you, and then you can work on B. So we're looking at A, given that these two are congruent, given that this is a 50-degree angle and a 130-degree angle, can we prove that it's a parallelogram? All right. Well, 50 and 130, these two angles, same side interior angles, are supplementary, so these lines are parallel. Now notice they were also congruent based on what we just learned. We know that, yes, this will be a parallelogram since we have one pair of opposite sides, both congruent and parallel. So we can say it's a parallelogram. Pause the movie, do the next one on your own, then press play when you finish. So this one's a little misleading. These two are congruent and these two are congruent. We do not have opposite sides congruent. We have consecutive sides congruent. So this would be no. We cannot determine it's a parallelogram. Let's look at these two. Pause the movie, try A and B, then press play when you are finished. All right, we've got these two sides congruent and we've got these two lines parallel. Now, that alone does not make this a parallelogram. Let me show you why. Because if these two lines are parallel, what I could do is take this line segment and have it go this way, and you could see that this guy would not be a parallelogram, but it meets the same conditions. So this would be no. Over here, because we have these two angles congruent, then these two lines are going to be parallel. And because we have these two angles congruent, these two lines will be parallel. So we have opposite sides parallel. Yes, since opposite sides are parallel. Here's an application of that. So we've got a truck on a lift. You can see that opposite sides are congruent in both cases. And so we've got a parallelogram. What is the maximum height that the vehicle can lift, can elevate the truck? So the maximum height would be 6 feet, and we can see we'll get a rectangle when we do so. This is a great slide just to summarize everything that was in this lesson. You can see that there's a lot of properties in this lesson. That's all for this